Welcome to G Fun Facts Online. Today, we are abandoning the idea of the static void. When you look up at the night sky, it feels silent. It feels empty. We see stars and galaxies as lonely islands drifting in the dark. But that is an illusion. The universe is not a collection of isolated objects. It is a single, interconnected, dynamic web. And recently, we have started to hear its rhythm. We are going to talk about a discovery that defies the laws of probability. A discovery that suggests galaxies separated by millions of light years. Galaxies that have absolutely no way of communicating with one another are moving in lockstep. They are dancing to the same invisible beat. This is the mystery of galactic synchronization and the secret physics of the cosmic web. Let's start with the news that shook the astrophysics community in December 2025. A team at the University of Oxford found something that, according to our standard theories of the universe, simply should not exist. They were peering into a cosmic void, about 140 million light-years away from Earth. Now, usually voids are empty. That is why we call them voids. But inside this one, they found a cosmic filament. Think of a river made of dark matter and gas, stretching through the emptiness. This wasn't just a gas cloud. Embedded within this filament was a chain of 14 hydrogen-rich galaxies. This chain is razor-thin in cosmic terms, yet it stretches over 5.5 million light-years. But the size isn't the headline. The headline is that they were moving. These galaxies weren't just drifting randomly, they were spinning. And they weren't just spinning individually. The entire structure, a colossus of a filament spanning 50 million light-years, was rotating like a giant cosmic baton. To give you a sense of the scale here, the rotation speed was clocked at 110 kilometers per second. That is roughly 250,000 miles per hour. Imagine a structure 50 million light-years long, spinning at that speed. Dr. Lila Young, one of the lead authors of the study, used a brilliant analogy. She compared it to the teacups ride at a theme park. If you picture that ride, you have the individual teacups spinning. Those are the galaxies. But the entire platform the teacups sit on is also spinning. That platform is the cosmic filament. This implies that the spin of a galaxy isn't just a local accident. It isn't just determined by how that specific galaxy formed. It is inherited from the architecture of the universe itself. To really understand why this is so spooky, we have to zoom out. We need to look at the stage this drama plays out on, the cosmic web. If you could fly out of the Milky Way, out of our local cluster, and keep zooming out until entire galaxy clusters looked like specks of dust, you wouldn't see a random scatter of dots. You would see a sponge. You would see a web. This is the scaffolding of the universe. It is made primarily of dark matter, that invisible substance that outweighs visible matter 6 to 1. In this web, you have three main components. First, you have the nodes. These are dense knots where thousands of galaxies congregate, like massive cities. Second, you have the voids. These are the massive, empty bubbles of space between the structures. And third, connecting the nodes, you have the filaments. These are long, thread-like highways of dark matter and gas. For a long time, we thought these filaments were just static bridges. We knew they were pipelines, channeling cold hydrogen gas into the massive clusters to feed black holes and start star formation. But the new discovery changes the picture entirely. These pipelines aren't just flowing, they are twisting. They are giant corkscrewing vortices of matter. Imagine being a galaxy born inside one of these twisting rivers. You don't stand a chance of spinning your own way. You are swept up in the grand rotation of the filament. You are synchronized with neighbors that are millions of light years away. It completely destroys the old idea of the island universe, where every galaxy is an isolated city with its own local history. We are not islands. We are bioluminescent plankton, drifting in a dark, swirling ocean. Now, you might ask, is this a one-off? Is this just one weird filament? The answer is no. This discovery is actually the smoking gun for a phenomenon that has been haunting datasets for over a decade. It's called large-scale coherence, and it is one of the biggest headaches in modern cosmology. Let's go back to 2014. A team using the Very Large Telescope in Chile decided to look at quasars. Quasars are the ultra-bright cores of active galaxies, powered by supermassive black holes. They looked at 93 quasars spread over billions, yes, billions, of light-years. They found something impossible. The rotation axes of these black holes were aligned with each other. And not only were they aligned with each other, they were aligned with the large-scale structure of the cosmic web they inhabited. Let's pause and think about the odds of that. The calculations showed that the probability of this happening by chance was less than 1%, but the implications are even crazier. How does a black hole tell another black hole a billion light-years away which way to point? There is no signal that can travel that fast. There is no force we know of that connects them over that distance, in real time. The only explanation is that they are both responding to a larger, invisible geometry that was imprinted when the universe was young. We see this closer to home too. It is called the satellite plane problem. If you look at our best computer simulations of dark matter, the standard lambda CDM model, it predicts that dwarf galaxies should swarm around giant hosts like the Milky Way in a messy, random beehive pattern. But when we look up, that is not what we see. The satellite galaxies around the Milky Way orbit in a neat, flat plane. The satellites around Andromeda, our nearest giant neighbor, also form a thin, rotating disk. Recent observations of Centaurus A confirm it has a synchronized plane of satellites too. This co-rotation implies that dwarf galaxies aren't just falling into gravity wells randomly. They are sliding in along specific, organized pathways, likely the cosmic filaments themselves, and retaining that synchronized motion. So the billion-dollar question, how? What is the physics behind this? Why is the universe spinning in sync? There are three main theories on the table right now. The first is the standard view, called tidal torque theory. The idea here is that as a cloud of gas collapses to form a galaxy, the gravitational pull of nearby structures tugs on it unevenly. It shears the cloud, causing it to spin up. This works great for close neighbors, but it fails to explain the new data. Tidal torque cannot explain why galaxies separated by 20 million light-years are moving in sync. Gravity just isn't strong enough over those distances to create that kind of lockstep coordination. This leads us to the second theory, which is what the Oxford team is proposing. They suggest that these rotating filaments are fossil records. They believe this spin isn't happening now. It is a remnant of the beginning. They propose that the spin was generated in the very early universe, during the initial collapse of matter after the Big Bang. As the primordial gas collapsed into dark matter sheets, it created massive vortices, turbulence on a cosmic scale. These ancient swirls never stopped. As the universe expanded, these swirls stretched out, becoming the rotating filaments we see today. So the galaxies inside them are merely preserving the angular momentum of the infant universe. When we look at a spinning galaxy today, we might be looking at a direct echo of the swirling chaos of the Big Bang. There is a third view, an alternative view, that we should mention. It is not the mainstream consensus, but it is fascinating. It is the electric universe theory, or plasma cosmology. Some theorists argue that gravity alone is insufficient to explain these alignments. They point to magnetohydrodynamics, the behavior of electrically charged fluids, or plasmas. If cosmic filaments are conducting massive electrical currents, known as Birkeland currents, through the intergalactic medium, these currents would naturally twist into helical shapes. This would create the corkscrew rotation we observe. While most astronomers stick to dark matter as the cause, the twisting nature of these filaments does bear a striking resemblance to the magnetic ropes we see in solar flares. It is a controversial idea, but in light of this new data, every possibility is being re-examined. Why does any of this matter to you? Why should we care if distant galaxies are dancing in sync? It matters because it fundamentally changes our picture of reality. It forces us to accept three things. First, the universe is a single organism. We can no longer treat galaxies as independent samples in a study. The universe is a highly coupled system. The motion of a star in a galaxy 100 million light-years away is mathematically linked to the structure that formed our own local group. We are physically connected to the farthest reaches of the cosmos by these dark threads. Second, it is a challenge to our models. Current dark matter simulations, like the famous Millennium Run, produce a cosmic web, but they struggle to reproduce the intensity of this synchronization. They predict messy, random spins. The fact that the real universe is so neat, so ordered, and so synchronized suggests our simulations, and perhaps our understanding of dark matter itself, are missing a key piece of the puzzle. And third, it affects the future of science. We are currently launching missions like the European Space Agency's Euclid and NASA's Nancy Grace Roman Space Telescope. Their goal is to map the shapes of billions of galaxies to understand dark energy. But if these galaxies are naturally aligned by filaments, it creates a false signal in the data. It mimics the effects of dark energy or gravitational lensing. If we don't understand this synchronization, we might measure the expansion of the universe incorrectly. We are standing on the precipice of a new era in cosmology. The static night sky is a deception. In reality, we are embedded in a churning, flowing, spinning web of unimaginable scale. The discovery of the razor-thin synchronized filament is just the beginning. It hints that the universe has a memory. It tells us that the rotation of a galaxy today is a direct echo of the past, preserved across 13 billion years of history. As we peer deeper into the dark, we find that we are not alone, and we are not still. We are part of a grand, rotating cosmic ballet, synchronized across the void by the invisible strings of the cosmic web. Thank you for listening.